Look at this image. You find a cute school-going girl with blue bag and pink umbrella along with her friends. Do you find some random dots here? Yes, we call it as noise. The question is it possible to convert this random noise into this beautiful image? Yes, it is possible. And that is what we discuss in today's episode of Truly AI, a technique called diffusion models, which is used in modern platforms like DALL-E. Welcome each one of you to this episode of Truly AI. I am Dr. C.B. Abraham. We are trying to do some simple experiment. We have got 2 glasses of water and fountain pen ink. Let us take a bit of fountain pen ink and pour into one of these glasses and see what happens. This idea of spreading this ink into this water is called in physics diffusion. In this case, we could be able to see that the structure of water is completely getting changed. This diffusion converts the one structure to another one. And this idea we use in diffusion models in order to create new images. And that is what we are going to see now, how we will be able to create images using this type of idea of losing the structure. The important thing is that we cannot convert this into this form, and that is not possible in the case of physics. Let us see how to use this idea of diffusion model to create images from random noise. Let us continue with the image of that school-going girl. Here we try to see how this adding noise will help a deep neural network in order to create an entirely new image. Here we have the image and also some rice. We use this rice as noise. Step number 1, adding noise. You could be able to see that the image slightly disappearing and the structure of the image changes. Step number 1, structure change happened. We add more noise. Step number 2, adding noise, structure changes. Suppose we have a neural network which could be able to keep track of what is happening. Adding noise, structure changes. Adding noise, structure changes. Step number 3, adding more noise and gradually the image getting disappearing and the neural network keeping track of what is happening at every level. Suppose we continue this process of adding noise. Each time we could be able to see that the structure is getting changed and gradually the complete structure is getting lost, and in this way we could be able to see that the original image is not seen and we could be able to see that it is a completely random noise now. We cannot have the original image identified. This is the random noise. Remember, the neural network could be able to have the idea of adding noise and the structure changes at every level. Therefore, this adding noise and corresponding structural changes could be able to be used in order to understand what noise can be removed in order to get the previous state. And this denoising process could be able to be used as a mechanism in order to create image. Therefore, from the random noise, using denoising, we could be able to move to the previous step one at a time, and correspondingly the model could be able to create and generate an entirely new image, and that is what we try to see now. Let us see how to create an image using this diffusion model. Suppose we want to create such an image of a school-going girl, and how we will be able to do that. First of all, we have to write a prompt. Let us assume that this is the prompt we are writing to the machine. a smiling Indian schoolgirl with pink umbrella and blue bag walking with friends on a rainy day. This prompt is given to the system. Correspondingly, system could be able to split this text into small parts called tokens. A token can be a word or a part of a word or a symbol, etc. And these tokens are converted to embeddings, the vector representations. And this collection of embeddings is the one which drives the creation of the image. This collection of embeddings could be able to create what is called a conditional signal and what type of image to be created. And for example, it gives a similarity or relationship between the different embeddings within this. For example, it will assume that pink is corresponding to color, school bag is corresponding to a child, and umbrella is corresponding to rain, etc. This type of relationship is identified, and correspondingly what is called a conditional signal is formed. And this conditional signal drives the process of creation of image. Remember, no creation of image till now, only the processing of the language. Now let us see what happens when we click on this prompt. See, a random process starts, random noise, starting the random noise, exactly similar to what we have seen in the example. And initially the random noise is created, the background noise is generated, and it takes some time, and you could be able to see gradually the objects are created. Each time it checks with the conditional signal whether is it the image the system is to be generated, and this conditional signal drives and forces in the denoising process. Anything not related with pink is removed, anything which is not related with the blue bag removed, anything which is not related with umbrella removed, etc. And finally we could be able to get such a beautiful image. And this is what the diffusion models does. Based on the text prompt, it could be able to provide a image based on random noise. We have seen how diffusion model could be able to create images from just random noise, and using the process of what is called denoising. Let us see how we could be able to refine this. For that, consider this: we slightly change the prompt, generate image of a smiling Indian schoolgirl with green umbrella. Instead of pink, we write green umbrella, and yellow bag walking alone. On a rainy day. We have slightly changed the prompt. Remember, the respective prompt changed, respective tokens changed, respective embeddings changed, and correspondingly the conditional is changed. The conditional is the one drives what type of images to be created. And based on this changed prompt, let us see how the image is created. And as in the last case, we are having the random noise. Only the background is created gradually, and it is taking time. Remember the denoising process, and the noise is removed one at a time and corresponding to the respective conditional noise. Here it is coming. The objects are gradually created, and we could be able to see in a small way how the image is created, and gradually the green umbrella is coming, yes, and the yellow bag is coming, and here is the school going girl with the green umbrella, yellow bag, alone. No friends. Remember, the prompt changed and conditional signal changed, and correspondingly the model could be able to generate an entirely different image. Therefore, conditional signal drives the process. Remember, system doesn't know what is an Indian. System doesn't know what exactly an Umbrella system doesn't know what is a school bag, but exactly based on the conditional signal, and the model could be able to generate image based on simple random signals. This is the process the diffusion model does, the refinement, the denoising of the one stage to the previous stage, and correspondingly the image could be able to be created. There was no schoolgirl sometime back. There was no pink umbrella. There was no school bag. There was no rain. In fact, we only had this random noise. We have seen how diffusion model could be able to convert a random noise to a beautiful image just by following the denoising part. And this is so beautiful, and this is what not only in the machines but even human beings we could be able to think about. Creation doesn't mean that adding more, and this is what we at Truly AI also believes in. We don't add more formulas, we don't add more mathematics, we don't add code, and we don't add jargons. We just denoise so that things become more clear. Hope you enjoyed this video. If you like this video, please like, share, and subscribe. See you in the next video. Until then, Truly AI.